Everyone, welcome back to my YouTube channel. So this is the factoring a quadratic from the virtual TI conference. And as algebra teachers, if you're an algebra teacher, you probably spend a great deal of time on factoring quadratics. And I'm always curious, how many are factorable? You know, we spend all this time. I hope a lot of them are factorable. So I'm going to create a nice quadratic where the leading coefficient is 1 and where B and C range from 1 to 30. So we'll keep those coefficients, those parameters, those coefficients positive. How many of them are factorable? So I've got my my Python program ready here. I'm going to, of course, do some sort of a count. So I'm going to set my count equal to 0. And I'm going to go through every single quadratic that I can. So for B in range, I'm going to go 1 to 31 for right now. We'll come back later and change it to 50 and see what happens. And then I want to do C the same way. So for C in range 1 to 31. And then I want to test it. So I want to use the discriminant to test if it's factorable. And so if the discriminant is non-negative, so greater than or equal to 0, and if it is a perfect square, then that quadratic is factorable. So I'm going to define my discriminant first. I'll call it D, creatively enough. And so I want D to be equal to B squared. And so that's 2, that's how you do B squared, minus 4 times, now the A is 1, so there is no A, so I'll just go times C. And then what I'm really interested in is, so if D is greater than or equal to 0, I can only do equal, and I want the square root of D to be equal to the truncated value. Truncated means I'm going to compute it and then drop the decimals at the end. The square root of D. So if my discriminant is non-negative, I mean, if my discriminant's negative, it's going to skip this step. It will not even do the if statement. I won't have any errors there. But if it's non-negative, greater than or equal to 0, and the square root of D equals the truncated value of the square root, in other words, there is no decimal, then that means it's going to be factorable. So I'll put a colon there, and I'll make my count equal to count plus 1. And then I want to print the C and T, and just to see how many there are. So I'll Control B and then Control R. And so 57 of them? Wait a minute, are you kidding me? So count out of, and then I want B times C. All right, let's see. Control B, Control R. So 57 out of 900 are factorable. Got to do the percent of that. So let's do, or the proportion, C and T divided by B times C. %. Let's list them all out. Every time it prints. So I want to print x squared plus b x plus c. I need that c. There you go. So let's run this. See what happens. Those are all my quadratics that are factorable. Yeah, that, let's see, 22, and yep. Anytime it's 1 less, it's going to work. So that's Oh, 19 and 1, 21 and 1. Oh, yeah, that's going to work. Let's see. So 30, 15 and 2, 17 and 1. 28, 2 and 14. Yeah, so these are factorable. Don't know which other ones there would be. We could probably print them all out if we wanted to, but really only 6%. So let's try this. Let's try this. Let's make the coefficients go to 50. Do you think it'll be more or less? 4%. 106 out of the 2,500 are factorable. Well, there you go. So give this a try. Let me know what you think.